Problem solving group activity pattern recognition. I considered not assigning this to you at all because I feel like this year it's difficult. So I'm doing it basically for you, with you, whatever. And all you have to do is watch this video, complete it, turn it in, and voila, instant points. Okay, so the shortest path from the school at the top of the following map. So here's the school right here. I'll highlight it. Where's my highlighter? The school at the top. There's the school. To the theater on Longwood Avenue at the bottom of the map. So here's the theater. The distance is 6 blocks. The shortest distance is 6 blocks. Okay? However, because our picture is set diagonally, more or less, there are more than one 6-block paths that could be taken to get there. So your job is to figure out how many different paths there are to get from the school to the theater. To figure that out, we're going to use a pattern known as Pascal's triangle. So this little activity is to help you understand the idea behind Pascal's triangle and how it works. Okay, so if you're standing at the school, how many ways are there to be standing at the school? Now, when I say standing at the school, so let's say, how many ways are there to get to the school if you're at the school? That sounds like a weird question, but we're going to call it 1 because you're already there. So there's 1 way to just be there. Does that make sense? How many ways are there to walk to this corner? Shortest ways. So theoretically we could go walk, 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 walk. Look, I got to that corner, but it took a really long time to get there because I went the longest way possible. Well, I guess not the longest, because you could have gone bleh. So we want just shortest ways. So how many ways are there to walk to this corner? Shortest ways. What's the second way? There's only 1 way from this corner to that corner. If you go any other way, then you're not going the shortest way, right? So you should be writing on your papers as I'm going through this with you. So there's 1 shortest way to get to that corner, and there's 1 shortest way to get to that corner, correct? How many shortest ways to get from the school to this corner? There's only 1. How many ways to get from the school to this corner? 1. So all the way down the sides, there's only 1 shortest way to get to any of these intersection points here along the edges. Because you're just going to walk straight to the place, right? So those are all 1s. 1 way to get there. Shortest way to get there. All right. Now that we've gone through all of those, let's start looking at other intersections in here. So what about this one right here? How many different ways are there to get there that are both the shortest way to get there? Why is that one 2? Because we could go do, or we could go do, and either way, it's 2 blocks. Doesn't matter which way we go, it's 2 blocks. So there's 2 different shortest paths to get to that corner. Does that make sense? Do you see what it's saying? Okay, here, let me undo my dots, and just so that this isn't quite as obvious. So there's 2 ways to get there. All right, now let's look at our next set of corners. How many ways are there going to be to get to this one? Let's try and figure that out by counting. Now, at some point, we might recognize a pattern, and then we can use that pattern to do the math for us instead of having to count every time. So this would be, we could go this way, that's 3 blocks. Or we could go this way, that's 3 blocks. Or we could go this way, that's 3 blocks. So how many ways to get to this corner? 3! I'm undoing those lines that I just drew, and I'm going to just put a 3 there. Okay, what about this corner? We could go here, or here, or here. How many different ways to get there? Again, it was 3. So 3 different ways to get to this corner, right? Do you see this little thing here that's showing you this pattern that we're creating? It has, so far, it has the same numbers we have written down, other than we've now added 3's to it. So there are 3 ways to get here, 3 ways to get here, 1 way to get here and here. We can keep continuing this pattern. Let's keep going. If you want to count, we can count. I'm picking a different color. Let's do red this time. So we're looking at this corner next. So that's going to be, we can go this way. There's 1. Count with me. Or we can go this way. That's 2. Or we can go this way. Here we go. So then we could go this way, which is a 4th way. So how many ways? 4. Okay, again, I'm just going to back out of these little sketches here. So we discovered 4. So based on what we've seen so far with the symmetry going on here, what do you think is going to be the number for this corner without actually counting it out? 4. Perfect. So I'm going to put a 4 there. Now, what about this one? Ooh, let's see. There's 1, 2, 3, 4. I don't even know where I've gone at this point. I think there's another zig from this way. One this way. 5, 6. There's actually 6 different ways to get to that corner. Now at this point, it's getting really confusing to count all these ways. So I really hope we can figure out a pattern at this point. So these numbers are 1s, that's a 2, 1 and 2, there's a 3, there's a 1 and 3, there's a 4, 3 and 3 and 6. Interesting. Anybody have any theories about what the pattern is? So Angel, go ahead and tell me what you think the corners are. 5?
5, because this is going to be 2 numbers added together will equal the next.
So 1 way to get to this corner and 4 ways to get to this corner means that to get to this corner you could either go through that 1 way or you could go through those 4 ways for a total of 5 ways, right? Which means over here is going to be the same. All right, what about these in the middle? Because 4 plus 6 is 10. 6 plus 4 is 10, so those are 10. Now let's do the numbers across the bottom. So 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. How long can you continue this pattern? 10 plus 5 is 15. You can continue this pattern forever. I'm not going to make you do it forever. On your assignment, you're just going to 16 rows. Just 16 rows. Okay, so let's answer the questions at the bottom of your paper. How many different 6-block paths can you take from the school to any corner along Longwood Avenue? So this is Longwood Avenue, and this is all of the corners to Longwood Avenue. We would actually want to add these numbers together to get that answer. I'm going to let you do the addition. My computer's being kind of jumpy at the moment. Okay, then question 2. How many of these paths will end at the corner directly across from the movie theater? How many different ways are there to get to this corner right here? There are 20. So I didn't finish this problem. You guys need to add it and find the answer, right? And then this side of your paper is done. Okay. You guys had a little bit of a benefit from being in class today because you got a paper copy of the actual assignment, which has a few numbers started for you. But I'm going to go ahead and do these notes after I save the one video I've done so far. So we will be back to this in just a